Welcome to Dear SQL DBA, a podcast for SQL Server developers and database administrators. I'm Kendra Little from SQLWorkbooks.com. This week, I'm talking about a question that I recently got from a student, but I've gotten it from different people by email over the years. We're talking about how do you analyze a SQL Server execution plan? Here's how the question came in this time. A student asked, I've got a terribly performing query and I've collected a complex execution plan for it, but I'm not sure how to interpret valuable information from the plan. Big picture, what do I do? How do I attack this thing? Well, we're going to talk about this and break it down. First up, what is an execution plan? When you submit a query to SQL Server, it needs to figure out, how am I going to run this thing? What indexes do I want to use? Can I do seeks on them? Do I need to scan them? What kind of joins, if you're joining different tables together, what kind of operations do I want to use to join these things together? Do I need to build, temporary objects? Do I want to do lookup operations? Should I use multiple cores to do this, or should I do it single-threaded? There's a lot of different things for it to consider. And the execution plan is compiled by the SQL Server Query Optimizer before it ever gets started running the query. SQL Server has to use things like statistics, these little samples of data that help it guess, hey, how much data will I be dealing with from this particular table? It also has to look at things in the query, like if you have parameterized values, it'll try to sniff out, hey, if I have to compile a plan for this, what are the values you're using for the parameters for this stored procedure or perhaps a parameterized query? Because, if you've got those values in a predicate and you're limiting the row by certain filters with those values, well, that influences heavily how much data is coming out of different tables involved in the query. So it has to make a lot of guesses before the query ever starts executing. And SQL Server doesn't reconsider the execution plan while the query is in mid-flight. There is a feature that's coming to us in SQL Server 2017 where certain query plans under certain conditions will have parts of them that are, quote, adaptable. Where on later runs of the query, SQL Server might be like, oh, well, that didn't work out so well, so I'm going to try a different tactic just for this part of the plan. But that's only in certain cases, and we don't even have SQL Server 2017 yet. So as of right now, with SQL Server 2016 and prior, optimization only happens before the query starts running, and it's all based on these estimates. SQL Server doesn't stop and think, like, did the query turn out like I estimated? We also have execution plans that can be reused. SQL Server doesn't want to compile an execution plan every time that you run a query if it doesn't have to. So it'll look at it and say, hey, do I have a compiled plan in cache for this query? And maybe you're rerunning it the same stored procedure or this same parameterized query. Maybe you're rerunning it with different values for the parameter. But in a lot of cases, it'll say, oh, good thing. I already compiled a plan for that. I've got it in memory. I can just reuse that execution plan. So an execution plan is a way that SQL Server guesses, like, this is going to be the best, given all my options, I think this is the best way to execute this query. And it makes that guess before it ever starts running the query. And sometimes it's using a guess that it compiled earlier, possibly for different parameter values. So when you get to asking the question, why was the query slow? The answer, why was the query slow? It isn't always in the execution plan. We have this additional factor, in addition to everything I've started talking about, like sometimes a query is slow for reasons that have nothing to do with the execution plan itself, or at least that aren't the fault of the execution plan. Maybe my query needed a lock on a resource and something else was holding that lock and it just had to sit and wait for the lock for a really long time. The execution plan was accessing a structure that was locked. So it is kind of related to the plan, but The cause of this is more like, okay, well, why was something holding that lock for a really long time, or what isolation levels are we using? And those aren't a problem with the plan, right? Is the issue that storage was really slow. Sometimes the query is slow for reasons entirely different to the plan, and you wouldn't know that just from looking at the plan. Things are changing fast, though. As of SQL Server 2016 Service Pack 1, certain kinds of plans called actual execution plans do have some information about wait statistics in them, but it's only that type of plan, the actual type of plan in SQL Server 2016 Service Pack 1 and later. Most of the time when we're looking at an execution plan, we don't have that information of, did the query have to wait, and if so, what was it waiting on? We also usually don't even have information in the plan about how long did the query take. Even looking at these actual execution plans, only if the SQL Server engine, not where you have Management Studio, but the instance you were running the query against, only in SQL Server 2014 Service Pack 2 and higher will you have information about how much CPU was used, what was the duration, and how many reads did something to do. And even then, it's still only those actual plans, only one type of execution plan. So how long was the query even slow? Many execution plans, when you look at those, most execution plans, when you look at just the plan, you can't even tell how long did the whole query take, much less how long did a specific part of the query take. So what all this means is that execution plans are absolutely valuable. I love working with them, and they make tuning queries much easier to me. But you do have to do other legwork to figure out things like, were there wait statistics? Was there resources that the query didn't have to execute that impacted it, right? That were outside of the plan's control? And how long did the query take in part and in whole? So having that extra information and figuring it out is a valuable part of interpreting the plan. I love plans. I'm not putting them down. You can get tons of valuable info for them. Just be prepared to dig for supplementary information to help you interpret that plan, or to know if the problem can be answered in part by the plan. When I'm interpreting plans, I think about a lot of different things, and I'm going to step through today just what are the types of execution plans, what is cost in an execution plan, how I think of it, what compiled for values are and why you should collect them, and then steps to interpret the plan. So types of execution plans. There are estimated execution plans. If you're going to run a query against SQL Server in Management Studio, you can say, give me an estimated plan for this. And SQL Server will compile, here's what I think I would do without executing the query. And these can be really useful because, hey, maybe your query takes 15 minutes to run, and you just want to get an idea of how much work do you think this is going to be without waiting the whole 10 minutes or using those resources. You can also see certain things in estimated plans that show up in a different way than they do in other plans. Things like functions. If you look in an estimated plan, they will actually show up in a more obvious way. I think they'll be broken out in more detail than they are when you're looking at what's called an actual execution plan. So sometimes you can get a really clear insight of, oh, look at all this work involved in this function broken out in a different way in an estimated plan when you look at that in Management Studio. But an estimated plan, it's just that, here's what I think I would do. Here's how many rows I think would come back from this. Here's what index I think I would use. We don't know, okay, how many rows are actually going to come back from that. So we just have information about, okay, here's the direction I think I'd head in. We also have cached execution plans. And a lot of times when we're troubleshooting a slow query, we are working with an execution plan that we have pulled from the memory of the SQL Server because we're looking for our top queries and we're saying, hey, based on the information you have in memory SQL Server, maybe I've got a nice way where I've said I want to see the execution plans for the queries that have the longest duration. And I pull these plans out of the cache. These cached plans can be reused. And I may have overall information on, okay, since this plan was put in cache, how much CPU does it take on average? What duration does it take on average? And also things like what's the max duration it's taken? What's the max CPU it's used? I have aggregate information like that. But with this cache plan, I don't know things like, okay, you estimated 10 rows would come from that index. Was it actually 10 or was it 10 million? The cached plan just has things like those estimated rows. It doesn't have details on actually how many rows flowed through different parts of the plan. And it doesn't have duration information for how long different parts of the plan took. I can kind of make some guesses based on those aggregate statistics, what I know about the tables and some testing. But again, I have to do some legwork to figure out, hey, is all of this estimated stuff in the plan, does it have anything to do with what actually happened when the query ran? The third type of plan we have are actual execution plans. And these are really, really valuable, but we have to be really careful generating them. One of the deals with actual execution plans is that, well, if you trace them, you may slow down your SQL Server a lot. Collecting them by trace is really expensive and can hurt performance. And you can get them by running a query yourself, but you have to run the query yourself. And sometimes that's not okay. Sometimes we have to, restore the database someplace else to be able to rerun the query, and that can take a lot of time. Sometimes, if the query is modifying a bunch of data, that process of running it someplace where it's safe to run it and then resetting the environment again to test again can be somewhat cumbersome. But actual execution plans can have a wealth of information, especially on SQL Server 2014 Service Pack 2 and higher, where we can get things like, okay, not only how many rows flowed through different parts of the plan, but also information on, okay, how much CPU were we using at this point in the plan? Takes a little while to get used to interpreting them because certain operators, that information is cumulative with its child operators, and certain operators it's not, but it's a wealth of information for us. We also get those weight statistics in SQL Server 2016 and higher. So depending on knowing what type of plan we're looking at when interpreting a plan is really useful. Even in an actual plan, one important thing to know is that when you're looking at cost numbers, they are always an estimate. Even though we call it an actual plan, all an actual plan is an estimated plan that's had some additional information added to it about things like, okay, what were our actual rows and what were certain actuals? But SQL Server doesn't go back and readjust the cost, and it wouldn't make sense to in a lot of ways. The cost information in the plan has to do with the reasoning behind why I chose these operators. If the cost was just sort of completely readjusted all the time, sometimes looking at a plan, it would make no sense why it had done that. So I actually like that cost is always an estimate. The important thing is just to remember that and don't fall into the trap of always just looking at the, quote, high cost operators. I do think it's valuable to look for the operators that have the highest. I will look at those in the plan and kind of be like, okay, this is what SQL Server thought would be the most work. It's very valuable information to know about how it optimized the query. Just know that it has to do just with those estimates and what it thought would be the most work, and that what actually took the longest in the query may or may not be those highest cost operators. This means there is no single shortcut when you're looking at a complex plan, there's no like single shortcut that just lets you know exactly where to look all the time to find the secret info. It's just not that easy. And looking at big complex plans can absolutely be time consuming. It's not that you're dumb. It's that it's hard and there is a lot to look at. One of the things that doesn't always show up right in front of you in the plan that I always want to collect though, is to check the properties of the plan and see what was this plan compiled for in terms of parameter values. Not all queries are parameterized. So figuring out, okay, look at the query. Does it have parameters is part of that. But if it was a parameterized query, what were the compiled for values? In a cached plan, if you're pulling plans out of the cache, make sure that you know what those are and you make notes. Okay, I'm looking at a plan that was compiled for these parameter values. One of the things that's tricky about analyzing execution plans is if you rerun the query for those compiled for values, it may be really fast. So, okay, well, when the query was run, when it was slow, was it being executed for different parameter values? Here's the bad news. Those aren't in the cached plan. It may be that the query is slow because of a parameter sniffing issue where like it's compiled with certain values and then it's slow when it runs with different values. The execution plan will give you the compiled for values, but you have to do the legwork to figure out, okay, what other values is this often executed with and why may it have been slow? Maybe that requires doing tracing. Maybe it requires looking in your application logs. There's lots of different ways you can research this, but that's part of the piece where like all the information we need isn't always in the plan. But when I'm interpreting a plan, big picture, here's what I do. I analyze. I step back, sometimes literally zooming out and look at the plan and try to figure out, okay, how is the data flowing through this plan? I'm thinking about where, I may start, kind of looking at the whole shape of the plan and then say, okay, I'm going to zoom in now on certain areas that are high cost. This is where SQL Server thought it would be the most work. But then I'm going to step back and kind of start asking questions about, was that really the most work? I'm not going to assume that those were the highest amount of work. I'm going to look at those values it was compiled for and note, okay, this was optimized for these values. So if I'm executing this for different parameter values, do I get different plans and how do they compare? Maybe something I want to look at if I suspect that plan reuse is an issue. I'm going to start noting likely suspects for why I think different parts of the plan that might be causing the query to be slow. And suspects include large row count. Maybe these are large row counts from a high, estimate. If it's just a cache plan, maybe it's just a high estimated row count. I don't know for sure. Was it right? Even if it is a lot of rows, I don't even know for sure if that was slow, but it's possible suspect. Do I see evidence of there being spills, or do I see estimates that I think might be way off? Do I see anti-patterns in the query plan where I'm like, oh, okay, we've got a lot of functions being used here, or we've got implicit conversions that may be causing a scan, and put these in as suspects. And then I set up a repro case and start testing things. I have to check out all of these suspects, and I have to check them out even if they're anti-patterns, because I have learned one lesson the hard way. When looking at execution plans to try to pinpoint what makes a query slow, this has happened to me so many times where there's something in the plan that's just the glaring anti-pattern, and it's a well-known thing you shouldn't do. And you start testing things out, and that is not at all why the query is slow. But if you start harping on it too much too early, then you really have egg on your face when you test out fixing that anti-pattern and it's still slow. Or maybe removing that anti-pattern, it gets even slower. So just because something is an anti-pattern, don't assume that that is what's making it slow. You've got to test that out and check it and know that most of these likely suspects are gonna be innocent, right? Execution plans and code are complicated, and you're gonna come up with a lot of candidates that might be making the query slow, and They just don't pan out. You got to just keep hunting and figure out, hey, what is the thing that's making this slow? If it's part of the query plan itself, and setting up that repro case and testing it is really where you start interacting with the query plan. You start testing out your hypothesis. I made this change. Now what happens? Does it get faster? Does it get slower? And that's really where you start the query tuning process. The query tuning process, you set up hypotheses using the plan and related info. The actual tuning process is when you dig in. Setting up a repro takes work. Sometimes you can't just run the query against production, and sometimes you aren't lucky enough to have a realistic development or staging database to work with. So sometimes you've got to set up staging data yourself outside of production so that you can test one part of a process. Because what if my query is slow in the middle of a nightly batch process and I've got to get it to the point where the data is right before that process begins in order to test the slow query? It's absolutely worth it to do it, but yeah, you have to do a little bit of work if you really want to test your hypothesis. Sometimes also I have a really complex query and I really want to work on part of it. I can try to break out that part of the query. But sometimes when I vastly simplify a query, everything changes, right? So I may have to do a lot of work to reproduce the behavior that I'm seeing in the problematic execution plan to be able to test it in a smaller format. Sometimes I also have to execute a query multiple times to get one execution plan in cache and then reuse it with different parameter values. But all of these steps in setting up a repro and testing it are steps where I learn more about the nature of the execution plan, how the data is really flowing through there, and why things are slow. So in this process of building the repro, I'm still working on the tuning process. I'm not wasting time. There are ways, of course, to save time. If you have a monitoring tool that looks at your SQL Server and collects information like how much CPU and how many logical and physical reads do queries use? How long do they take? And what are their cached execution plans? That can be helpful because when you're looking at a plan and you want that information of, okay, at different times, what parameter values is it executed with? How slow is it? You have a place where you can go get those. You don't have to set up a new trace or run a bunch of queries to figure it out. If you have SQL Server 2016 and higher, the built-in query store feature that you can enable per database collects much of this information. A lot of it is in aggregate form. It's not as detailed. It is not a monitoring tool, but it has aggregate information that can help you figure out, hey, has this query had different execution plans over time? And for different intervals, what were the execution statistics for that query plan in that interval? They are an aggregate, but they persist over restarts. They're a lot more stable than just hoping the information you want is in memory, and that can be really helpful, and it's built right into the SQL Server. So there is an art to pulling this all together. Which parts of the plan are taking the longest? What should you do to change the behavior, right? Because even in an execution plan, even when I've analyzed here's the part of it that's slow, I then have to start making additional guesses about, okay, well, here's the part that's slow. What do I do to make it faster? I have absolutely found this to be the case where I do a lot of work. I figure out exactly which part of a complex plan is slow, and then I stop and I'm like, oh geez, how do I fix it? There's no obvious option, and I've got to be a little creative with saying, okay, do I need to rewrite the query? Do I need to create an index? Do I need to change an index? Like do I need to use a hint? What are the things I can do to influence SQL Server's behavior and then to test them? And very often the thing I want to do to change the behavior may make the query slower. So I have to actually make sure that my change will reliably make the query faster, even when it's optimized for different parameter values, right? So as you go through this process of narrowing down which parts of this query are making it slower, you'll learn more about the query, and you're really not wasting time, because the more you learn about the query, you're going to use that information when you have to start guessing about how to make it faster as well, and trying to make it faster reliably. The more that you break down execution plans and kind of dive in, it can be frustrating, and you're not going to have a success every time. Trust me, I have not had success every time I've looked at an execution plan. You do have to go out and say, okay, I need to figure out more information. I need to set up a repro. I need to get an actual plan. It will take work to do that. The more you do this, you will become faster at it. You'll develop those suspects more quickly, and you'll come up with different tests you can do to see if you can make it faster more quickly as well. And I think it really becomes more fun the more you do it too. So I hope these notes on how I attack execution plans in general are helpful. In the courses I record on SQL workbooks, I try to give you concrete examples of execution plans to troubleshoot, and you can absolutely use those demos in those courses and say, okay, I'm gonna take this plan and try to make it faster myself before I step through the course too. So try to take opportunities where you can to get practice, and I hope that you start having fun with it, which is really what I do most of the time. There are always those plans that just lead to frustration, but I'm always happy to come back and fight another day. Thanks for joining me for Dear SQL DBA. I'm Kendra Little from SQLworkbooks.com.